Good morning. This is a piece of very applied work that I'm going to talk about, and it fits quite nicely with some of the things we've already heard. The work was almost entirely undertaken by Greg Guerin, but he's unable to speak here, so I'm taking up the speaking part. The work was done jointly between ourselves at the University of Adelaide, Turn. I'm in the Centre for Global Food and Resources with Sarah, and with Juna, with Sandy Carruthers' group, Dan Rogers leading that, and this follows on from some work Dan Rogers has done on ecological climate change classification for South Australia, but this is taking it more broadly to the wider pool of South Australian regions. The reason we got into this partly was this alone, but also it was about these compounding effects. So we actually started with an interest in grazing pressures and kangaroos and other things starting to impact by preventing recovery and restoration in native vegetation, and then saying, well, if we were going to prioritise where we would think about taking actions for managing those problems, we really want to take climate change into account. And so we need a better classification of where our vulnerabilities lie, to start thinking where would we take actions for restoring, where would we take actions for management. So it is about the compounding effects. So it's a fairly simple concept of what we're trying to look at here is on one axis is really the sensitivity, the impact of climate change on something that we're interested in this case on ecosystems, and using native vegetation for looking at the impacts of climate change, and then looking at some measure of resilience. In this case we used the remnancy, so the amount of fragmentation or where we still have remaining vegetation within highly cleared landscapes, and so combining those two things together to understand the vulnerability of systems. And the sensitivity measures that we use from an ecological perspective is really species turnover. So beta diversity, how much are systems changing across the landscape, and so when we have spatial effects from climate change, where are they going to hit home hardest? So that's the intent. To locate those vulnerable landscapes, we used a 25 kilometre radial buffer zone for the remnancy component from previous work that Greg had done. We used species composition models from plot data from the Biological Survey database and Turn, so about 300,000 records involved in that, and we used some dissimilarity models to look at that species turnover, and it tested that with a range of environmental and spatial variables to understand what's driving species turnover or beta diversity. And then we used a whole suite of climate change variables and spatial variables that might start to show us something that was predicting turnover. And the three big ones that came out after some backwards removal of things that we didn't think were having very much impact, the three big ones, which vary slightly across the state, but they are the mean annual rainfall and mean maximum temperature of the warmest month. They were very important, and as we get into the into the Flinders Lofty block, then relief becomes important as well. But other variables had some part to play. These variables statewide explained I think 63% of the deviance, so quite very high for such a large spatial model populated by the field data and other things. So the modelled species composition for South Australia, looking at the grain of how are systems changing across the landscapes, and the big picture there of the state is at a 1/4 degree scale, but then we're able to home in on two sub-regions, if you like, or two regions in South Australia, the Eyre York block and the Flinders Lofty block, and they're at a 1/10 degree scale, so much more intensively sampled, and so better spatial resolution. the colours don't quite match between the two because of the change in the intensity. But you can see there's some sharp reliefs around certain things, probably driven by the temperature changes, hottest mean annual temperature of the hottest day, and then relief around the ranges. So the species turnover was very high, between about 200 and 400 millimetres a year. So there's a zone within South Australia, within that semi-arid, reaching into the arid zone, where there was very high species turnover boundaries, and so highly sensitive to potential climate changes. We then put that together with the climate models. These are all from the RCP 4.5. But the differences between the different scenarios were not so great, so I'm just showing the one here. There's a paper on this if people are interested in it. It was primarily done for the department and to look at these things as an applied problem, but we have produced a publication out of it so that it's more widely accessible. What you can see here, the intensity of the colour there, so the reds are susceptible. If we go back to that, if we go back here, you can see that the worst situation is the sensitive zone, where we have high ecologically scaled exposure, and susceptible is worse, where we have low remnancy and high exposure, and then we work our way around anti-clockwise, essentially, to how bad is it going to be in those locations. So when we go back to those similar colours in the classification, you can see that the most susceptible areas are through the mallee wheat belts and the upper southeast. So this is where we have low remnancy. You can see that there's some spots popping out there as sensitive within those landscapes, not susceptible, where we have large pieces of native vegetation remaining through preservation in parks, etc. But there's really, it's in that 200 to 400 millimetre rainfall zone that we have the highest vulnerability when we take into account the remnancy effects on resilience. The Northern York and Northern Flinders is sensitive, and I know that in that areas there's work looking at where refugia are and using relief as part of that refugia planning, and the bottom of York Peninsula also is in a better situation, it's more resilient. And of course the north of the state tends to be more resilient on these scales because we have higher remnancy, so we have lack of fragmentation, though we have quality concerns. And there are some areas that have some resistance, so the northern Mount Lofty Ranges, southern Flinders and eastern Kangaroo Island. We did include, and in the paper there is some analysis of climate velocities, so how fast do things need to move to be able to stay in the situation they're in and not become worse. And that's concerning, and the climate velocities sort of averaged across the southern part of the state are between 1 and 9 kilometres a year. So that's concerning, but look at the paper if you're interested in that. What are we going to do with this? So as I said, we sort of started here with the idea of where would we concentrate our efforts. So we now know that mallee wheat belt in all three of those natural resource management regions is very important, and that's an area where we should be thinking very seriously about our restoration efforts, our interventions there, and we should also be thinking in that about our provenance selections. There was a question in the first part of in Leslie's talk today where, and Trees for Life and the Environment Institute from Adelaide Uni, we've done some work on provenance selection and trying to move that thinking along from local is best to we have to be planning for a much wider range of threats and risks than the old stuff. So choosing to restore, choosing how to manage, spatially planning those things. My primary interest here is in incentives for change behaviour, for restoration and native vegetation management, and designing incentives around some of these risks adds another complexity, but it's very important to get this stuff right spatially. In susceptible areas, these are the high priorities for this restoration, but we might need this predictive provenance selection, for example, where we're taking species from perhaps 100 kilometres north that have better adaptation traits, and if not, making that the whole thing, we have experimental designs where we can start to look at survival and reproduction for species. We need to start combining this stuff, so all of this work is available through the OCOS websites, and so other people can use these models to take it further, and we need to be looking at this. We are looking within this around grazing issues. Tom Prowse is giving a talk about kangaroo populations, but he's going to throw a little bit of the work on grazing impacts into that. I think that might be tomorrow, Tom speaking, maybe today. So we need to be combining this with other information for prioritisations. And we have some other work going on around co-benefit production from carbon sequestration and taking into account climate. The climate vulnerability classification is really important in that space. People are taking long-term risks. We have to have long-term thinking about what risks they're taking, particularly if we're trying to attract investment from multiple sources. And of course we need eventually to go to finer scales. So these are at where the big data is, but if we start homing in on areas that are of particular significance, then this will play a role. Thanks.